Well, thank you to the GRCA to give me this opportunity to present to you today. My name is, sorry, I just started with water and coughing. My name is Markus. I work for a design company, a multidisciplinary design company, and I was the project director on Crossrail, or what's now called the Elizabeth Line. So we inherited a great architectural intent, and we did our part to turn it into reality by doing all the associated specialists, engineering and fabrication modeling. And sorry, it's not a good start. First slide. Yes. This is going okay. Sorry for that. I would actually like to start a bit different to what we sometimes see in social media. I would like to say that a lot of companies should be standing here today with me, because this was a big team effort. There was, of course, the great architecture created by Crossrail, Grimshaw, and the station architects. But then today the event is about GRC. So GRC UK is the company that fabricated all the panels that you're going to see in a moment, and managed the project with all its associated steelwork. Big investment by their mother company. I think the output of the GRC company of GRC UK went to 5 times of what it was before the project, and of course the installation teams and the different suppliers. I just thought I would like to say that, and that we did this all together, and I have the honor to be here with you. But really, the result we achieved all together. So to briefly, I guess that a lot of you came in today via Tottenham Court Road, so you might have seen some of this live. Also, I wanted to offer, if anyone wants to see the result of this, I'm going to stay around after the presentation, and I need to go back to Tottenham Court Road anyway. If anyone is interested, feel free to come with me, and I take you for a walk through the station and some more explanation. So the architectural brief for this project was to create this exceptional GRC cladding for the 5 London inner city stations. So you see a few images here, and we designed 3 of them: Tottenham Court Road, Liverpool Street, and Whitechapel. And here's some early architectural images that we received. I think these are from Crossrail and Grimshaw, and just to give, for the ones who haven't been in the station, to give you an idea, is this is about 5 meters high. So these curved a base. So this is about 1.5 meter wide. So our role when we started with this was to not only just take the architectural design and turn it into fabrication design and do all the engineering that goes with it, but there was also this whole project was priced by most companies in the big recession, and then things got a bit better again. So it was like a big. So everyone was working with big budget pressures by the time the project really got going. So we did a big value engineering exercise. We tried to maintain the architectural intent, but reduce the amount of different panels on the project. There was like a lot of challenges with the back. Is like I guess most of you work with GRC on buildings, and this was a tunnel against sprayed concrete, which is like you've got like always against your face, and overuse, a very difficult installation and transport conditions. But so really, when we started this project, I got a drawing like this, and I thought, oh God, this is going to be the most boring project of my life, a few repeated bays across a platform and a few junctions. But I was very, very wrong. So when you look at it, 3 stations, there were over 3,000 unique molds. It's about and about 32,000 panels to be produced. So we did a big exercise to make some minor adjustments while trying to respect the architecture really to the millimeter, because it's so unique, and we got it down to 2,300 unique molds. But it was still it was a huge project for us as designers, and as I said, for GRC UK and a lot of suppliers. In fact, if I remember correctly, I think the whole you would know better than me, but I think the whole GRC industry in the country didn't have enough volume to deliver this project, and that's why a lot of investment was necessary in additional manufacturing capacity and work together between different companies. And so, how do you then go about that? And so we started with a prototype, and there's you might know him. Remember David Schilleter from Langewerk? He said he had, I think, a great vision. He said, let's pick something really difficult and not just like a mock-up to get through the approval process. So we picked this junction. This is a junction that really exists at Tottenham Court Road. Is double curved because you have tunnels of different radii intersecting, creating curves that are, for me, even after all this year, difficult to understand sometimes. And so what we developed, we developed a ladder frame system based on cold formed steel in always like a frame which was braced and stable in itself, and then the one in the other bay, another one, and then in between an infill bay where we just put some struts in between. And what we tested in this mock-up first was to say, so let's, as I said, pick something really difficult. And one thing that nobody can see is that the platforms, they were at the gradient of, I think, 0.09 degrees. So even though this was all already so complex with so difficult shapes, it was even worse than it looked like, because it wasn't even symmetrical, because the left side was like 20 millimeters different to the right side. So really tricky. So and then we tried this out, and then in the you'll see this later also in the pictures. What we said, we couldn't imagine how to produce a steel frame that like curves in 2 directions and picks up some panels and really get it into the right place. So what we did is this thing here, which you see at the back, is actually it's a big GRC panel, but not an architectural visible panel, but it's actually the structure. So we used GRC in 2 ways. We used it as the backing structure in the most complex areas, because we just couldn't see how we could get anywhere close to the desired geometry, and then we hung panels from it. Then going further, so this is how it looked in reality. This was so built in the Explorer precast factory in workshop, and they actually, for some reason, they took it down like 2 years ago, I think. But I think until then it was probably the biggest tourist attraction in the place, because it was just such an exciting thing to look at least from my perspective. And then you also see there's all these endless holes in there. So building in a tunnel in a station, you would maybe in the first moment think, well, that's not constantly exposed to rain and wind, etc. So it's maybe easier, and probably in some aspects it was. But on the other hand, we had to deal with really tricky acoustics. So all these holes in there, they were of course part of the architecture, but they had a special insulation behind that needed to be tested and recalculated to just absorb enough of the sound in the stations to get a good acoustics across the stations. And then there were and as part of this whole prototyping process, we also, of course, we tried out the installation, tried not to cheat because in a mock-up it would be easy to just go behind and do it in an easy way. But so the guys from GRC UK they did this really really well, and that benefited the project later. Then a little bit about the engineering about this. As I said, there was like almost any project has a cost pressure, and there's always an expectation to make things a bit lighter and cheaper, etc. But yeah, as I said, it was like most of it was priced in the big recession, and then like by the time we got to actually doing this in 2013, 14, 15, prices had gone up a lot, so it was really even more important than normally to find some efficiencies. So we originally the design intent was for curved hollow sections, and then we did like endless analysis on cold formed steel sections, and then worked out a way together with the manufacturer to facet rather than roll them, to cut out that process, and yeah, a lot of detailed design, and then of course the GRC itself. I think so. Some of our engineers they probably knew the GRC guide out by memory after that project was really important to have it. I don't know otherwise what we would have really done. And then, but what we also, so at that point, for us as a company, and for me as a person, GRC was something relatively new. This was the first time that we took on this role of a specialist designer for the material. So we complemented all this engineering with tests, some of them like really simple, and it was just reassuring to see how much plastic deformation there's in the material. And then we did on the right hand side, what you see here is we took a typical bay. We spent so much time with some of the engineers in the whole approval process, because there were like the whole contractual chain. There were probably like 4 different companies involved that had to check and approve. And so at some point, this is taking so much energy that we said, well, in addition to doing all these endless calculations, let's just test it. So we tested like a typical bay to 11 times the load, and it still didn't fail. So again, I don't know. To me, it was just like an illumination how much GRC can actually resist. And this is after we made the panels much thinner than they were meant to be from the design intent. And then really exciting, we worked with a guy called Chris Stevens, super competent security expert, and did some blast tests, which allowed us to further value engineer. It was like I don't know if I guess the British people of you notice in Northern Ireland they had these steel boxes for the police to protect against bombs, and so we got into one of these about like 100 meters away from where the panels were tested, and there was like the big bang, and then we were just hoping that the panels were still on on the wall when all the dust cloud disappeared, and it was a really positive surprise how well the GRC behaved, the ductility in it, and we theoretically we could have taken the panels down to like 6 millimeters, I think, but we didn't do it. I think one of you explained before about the face code and that, and so we left it, I think, at 10 millimeters, the thinnest panels. But it was a huge difference at this scale of the project. And then things like that about weight reduction. So it wasn't just only about like save a bit of GRC, but also to try to get the panels below a certain weight to be manhandleable between two people. Not in the installation actually was primarily with small equipment and only the last push by manually, but all the loading and the factory movements, I think it made a big difference to try to get the panel weights down a little bit. So this is what we achieved by all the testing and endless calculations. So basically a reduction, but to less than a half on average. Then, like, this doesn't look like a very exciting slide, but this was really tricky. Like, so you all know, like on typical buildings, there's always some tolerances. The slab is out of level or position, etc. But here it was really tricky because we had to connect the frames and panels in some position which wasn't vertical or horizontal, but just somewhere, and still deal with tolerances and the SCL for people to the sprayed concrete. For the ones who have never seen it, this is a really rough surface, so really difficult to deal with. And then what we then had to do is, because there was like a lot of parts were actually out of tolerance, so we made a big overlay of our models against point cloud survey of the tunnels, and then we identified where the panels and the support structure would clash, and then we worked with the contractor on site at the stations well, in some cases we did some acrobatics with our frames and GRC. In some other cases we had to just like scabble back the surface of the tunnel a little bit, and it was so this happened so many times in the end that we then developed a parametric tool that would automatically redesign frames and panels to take the obstructions into account. And this is 8 years ago, so it's a technology that has evolved and could be better. And I think, irrespective of whether it's GRC or tunnel, I think that could be used on many buildings and construction sites and benefit any project really. Yeah, just like another picture of the overlays. And then, yeah, so as I explained before, we were doing this. Unfortunately, you cannot see these anymore. So these are the structural elements. We called them tasks. So these were huge pieces of GRC which created exactly the shape with some big heads cast and exactly in the right place to receive the finishing panels. This was an idea that one of our founders came up with, and then we really did it throughout the project. Maybe the next slide makes this a bit clearer. So if you imagine you have so the left side is a junction of tunnels with different radii, and you somehow have to build in some steel in there and like create offsets in the three directions to receive panels. So it's of course much lighter, but with this, so you put all the effort into the manufacture, but when you arrive, you just put the panel in and that's it. So we did both, and I think it's was was an interesting concept. It's just like now it's sad that you cannot see these elements anymore for 120 more years, because we had to design this for 120 125 years of design life. And then we had a team that went up to 30 people at the peak of the project, and most of the work was actually not the engineering and the coordination and the acoustics, etc., but really to model everything. And here I've got a video for. No, not yet. Sorry. So we modeled this all, and this is something this again looks like a boring slide, but I bring it up again because there's so much talk about BIM, and so much about like just purely complying with a BIM plan of a client or a government department. But what do we actually get out of all this effort? And so what we did on this project, again with a guy from GRC UK who had like a really good vision about that. So we actually did more than was necessary in certain aspects. We put like every washer and bolt and nut, everything had a code in there that would define which supplier it came from, which position it needs to go at what time, and then they linked it into the subsystem. So this was really tricky. The volume, imagine 32,000 panels across 3 stations, some of them identical, but a lot of them not, and the same identical piece coming out of different factories because there was just not enough capacity in the individual factories. So it was a huge so logistics challenge, and I think this made a real difference to it. So I guess my message sometimes when I'm asked to talk about BIM is yeah, we can do everything and like for compliance, but I think sometimes what we should do is to just have 5 minutes and say, so what of all of this is actually of use to me, and what could I do, and maybe do a bit more in these areas, and maybe a bit less in others where it's of not that of no benefit. And yeah, so now I wanted to take you on a virtual tour through our fabrication models. So this is starting with Whitechapel. So again, just for scale, so each of these bays is like 1.5 meters. This is about 5-6 meters high. So a lot of different platform bays with benches, lights, signage, etc., junctions for the cross passages. And then like the highlight of most stations is like the big trumpets where you go down in the escalator. And then moving on to Liverpool Street, it's the biggest station biggest GRC station. It's a huge volume again, like very difficult geometries everywhere. Also with these intersections of a few rectangular passages against circular, so you get geometries that you haven't even dreamed of before you get to this project. And then this one is Tottenham Court Road. So as I said, like anyone who has 10 minutes time, I would has never been, definitely while you're here, go and have a look. It's really great. It's like I still sometimes take pictures myself down there. Yes, and then this was out of the coordination model, and then for each of the bays and junctions, we then created some super detailed models, and part of them had again codes in them that would automatically drive the machines, the CNC machines that cut out the molds, and for the panels you see like every bolt and nut is in there, even like little tethers, security tethers, etc. So it's a huge amount of work. I think it took us like 4 years to get through all of it. Yes, and then these again the red ones is this the GRC used as backing structure rather than as finished elements, even though it deserved to be seen, I think. Then a bit some images from GRC UK's factory about the production. There's these acoustic holes. They were particularly tricky to deal with because of the geometries and the demolding moment, because you just got stuck because of the angles, and we had a lot of discussions with the architects, as I said, trying to maintain the intent. Some cases we did manage to split some panels to just make it a bit easier, but in other cases we had so the factory had special solutions with some of these acoustic holes. They had to be then I don't know taking out before from the back before demolded in general. So it was really tricky for everyone. Then these ones, this is the CNC machine for the mold and the big tasks. Steelwork, I know today it's about GRC and not steelwork, but this was also we asked the factories to work with templates so that identical pieces that are meant to be identical really come out as close to identical as possible. It was also like a lot of specialist welding and weld distortion that we had to deal with, and the two factories, I think they did a really good job for that. And setting out, how the hell do you put in a panel which just used somewhere there is no grid, a grid line against a vertical or horizontal surface, but just somewhere. So that was really difficult as well. So what we did is so we had this model where the fly through came through, which then we exported coordinates of very specific points, and I don't think we can see this right in these pictures. And then we picked specific points on the steelwork where where the factory is etched in a cross or a line to really know which point are we actually getting into which position. And in the end, I think this also worked well. The use of digital data rather than a lot of paperwork, because it was just too difficult to put it on paper because of the geometries. And what else have I got? This, and then because it's in a tunnel, really tricky to get certain pieces into position. So they were called I think the mole holes. So certain openings where the lifts would go in later, where we had to lift and then turn and somehow get it around the corner with special frames. So remember, this is the first task from Tottenham Court Road. We planned this for really long, and then the guys there they just did it, and we only heard of it the next day. So it was really, again, I think an example, with all this digital and teamwork worked out well. Installation set some. This is what so the ladder frames and the panels. Really, again, very tight specification on the side from that, just aesthetically to keep all the panels perfectly aligned and at the visible surface. So what we actually did was I think perceived as a gamble. We said we put all the effort in the fabrication. We don't allow any installation tolerances. So this was all installed without shimming and adjusting, but it was factory control, and then once it was in the right position, it just went up. And the first station of course, like you do these things. It took a bit, but then I think it worked out well. And then on Liverpool Street, I just remember they were so quick, we just couldn't keep up with them. We were like, they were just too good. The installers, they overtook us all the time. Yeah, and then just another pictures. Again, just a last time as I have the honor of standing here, but really the company that fabricated and managed this is GRC UK. Deserve a lot of credit for this, and some final statistics. So it was a huge project, 32,000 square meter of panels in all kind of shapes and trumpets and double curved and single curved. Was like, yeah, mind blowing, and I think a once in a lifetime project, unless anyone of you has a similar project, which we would love to do. And yeah, the 3.7 million acoustic holes. This is just like the poorer guys who had to model this, but also the guys in the factory who to demold, so put this in and demold it was a lot of work. Here are some final impressions. I did. This is already my last slide I had because of copyright issues. I just didn't know which pictures I could show, so I went into the station myself. So forgive me. This is my photographic talent is not that great, but I as I said, I hope you can see it for real. And yeah, that's it. Thanks a lot for having me.